Hello guys, welcome back to my YouTube channel. My name is Yasser Ahmed. So in this video, we will continue to look at the ICT IGCSE course, and we're going to be now focusing on Chapter 4, Networks and the Effects of Using Them. So in this video, we will be looking at 4.1, Networks, and we will start off by looking at the purpose of a router. So first of all, you might recognize this device, and you might have something similar in your home. And what is the purpose of the router in your home? It's basically to connect to your devices, copy your mobile phones, tablets, laptops, desktop computers to the internet. So it will connect to your computers or your network to the internet. That's the first thing. But the router does so much more than that. So let's have a look at this little diagram here. So this black line here represents the internet. To be able to get onto the internet, you need an internet service provider. Okay, and you may have one or two workstations. If you have a little network, these workstations may be connected to a switch, which we'll come to later on in this video. And then you can see the routers here are basically directing packets of data. So you have incoming data, outgoing data across the internet to different destinations or to different routers. So obviously you will have data coming into your computers and data coming out of your computers, and the data will be split into packets. So what does a router do? As well as connecting your devices to the internet or your network to the internet, it can connect local area networks or networks together to form wide area networks, and we'll also be looking at that later on in this video. It will transfer data between networks, so it will receive and send packets of data. It will store addresses in its routing table, and this will help determine the best route for the packets to take to get to the next destination using the most efficient methods. What you don't want is to create traffic on your network, so the data is coming very slowly. You want to send the data using the most efficient routes, so the data can be sent and received in the most efficient way and the most quickest way. So routers can connect devices using cables or wireless signals to the internet. Instead of transferring a huge file as a single block, sending it small packets will improve transmission rates. So how is data sent over a computer network? So it's basically divided into packets, and each data is broken into packets, and each packet can then be sent in a different route. So instead of sending one block of data, we're splitting it into different packets which can take different routes over the internet. The router will control the route a packet takes, finding the most efficient route. The packets may arrive out of order. Once the last packet has arrived, the packets will then be reordered and put back into the right order it was sent initially. Okay, so the data packets, each packet of data will contain a header, which will identify the data packet, and it'll also contain the sender and receiver's IP address. So we'll come to the IP address in a moment, and a number of data packets making up the whole message, so the whole block of file, so whole data block. Right, let's have a look at this next diagram, and we'll be looking at the routing table as well. So here's your workstations. They're connected to a switch, and then these can be connected to different routers, which can direct your data packets across the internet. Web pages on the internet will be saved onto web servers. So, for example, you might have Facebook, Outlook, YouTube, okay, and we want to receive and send packets of data to our computers. So the routers will be directing those packets of data into our computers and out of our computers. And how does it do this? So it uses something called a routing table. So the routers will store IP addresses in a routing table. The routing table will contain a list of different routes to other networks, and a routing table is used to determine the best route to use when sending data to another network. So how does a router send data packets to another network? The router receives the data packet. The data packet contains the destination IP address. So this is what an IP address will look like. And everything connected to the internet will have an IP address. So any device you have, like a phone, a tablet, laptop, etc., The IP address is assigned to your computer or network interface card, and it uniquely identifies your device onto a network. And IP addresses can show your physical location of a device. So if you're basically connected to a network, to the internet, you've been sending, let's say you've logged on from a location, the IP address can show your physical location. So the router will look at the destination IP address in a packet and will compare it with the addresses in its routing table. And then the router will determine the best route to the next router or destination for the data packet. Okay. So here is a typical exam question. A router is used to connect a local area network to the internet. A message is sent from the router to another router. Give the name of the part of the router where the IP addresses are stored, and the answer is going to be the routing table. So the routing table stores IP addresses, and then the routing table contains a list of different routes over networks, and it will determine the best route to use when sending data or packet data to another network. And explain how the data from a router is routed. So data is sent in data packets. Each data packet contains an IP address of the next router or the next destination. The router then checks the IP address and checks the IP address against this routing table. So the data packet is then sent to the router with the IP address, so using the most efficient route. The router will then use the IP address to work out the best route destination, and it will store the IP address of that destination. So that's the typical sort of question you may get asked about routers. So just to recap before we move on to the next part. So routers obviously can connect your device to the internet. It can connect local area networks together, and it will be receiving and sending packets of data. Okay, and the routing table is used to help send the packets of data in the most efficient method. It will work out the best route. It will look at the IP addresses in the routing table to determine the best route. And once all of the data has been received, then the data will be reordered back into the right order. So obviously the data packets are sent into different, chunks, you could say, and it may arrive out of order. And then once the last packet has been received, it will then be put back into the right order. So in a network as well, what you may have is a hub or switch which connects a number of computers to form a local area network. So the hub and a switch has a similar sort of responsibility, okay? But a switch is known as a smart device and a hub is known as a dumb device. So let's start off with the switch. So computers will be connected to a switch, so via network cable. So you can see there's little ports here to connect the network cable into. And specific packets of data can be sent to specific computers on a local area network using unique MAC addresses. So the switch will use MAC addresses to send specific packets of data to specific computers. So this will mean it's more secure, however more expensive, and it's typically used in office environments, in school networks, and so on. So you can see this diagram here. This computer is going to use the switch to send a packet of data to this specific computer using the unique MAC address. Okay, so and the MAC address can be identified or each workstation will have a unique MAC address when it's connecting to the network. Okay, the hub is a dumb device because what will happen is it will send all the packets of data to all the workstations on the network, which will cause network traffic. So you can see we got to send something to this computer, but we don't know how to send it to this particular computer. So what the hub will do, it will send all of that data to all of the devices on the network, which will lead to poor security and would only be suitable for a small home network. So obviously this would be a cheaper option compared to purchasing a switch, which is a more expensive option. Okay, so the difference between a switch and a hub is the switch will send a packet of data to a specific workstation on a network using a MAC address, and it will learn a MAC address. And a hub, it's not a smart device, it's a dumb device with poor security, and it will flood the network and send that same packet data to all of the workstations on the network. And here's a typical exam question comparing and contrasting the features of a switch and a hub. So a switch and a hub are both network devices, both have computers and devices connected to them. Also, the hub and the switch both send data to devices. However, a hub will broadcast data to every device connected to it, and the hub is less secure. A switch checks the data packet and sends it to the appropriate device using the MAC address. Okay, and in each computer, you will have a network interface card. It may be built into the motherboard or maybe a separate device, as you can see here. So this is a desktop computer, and a cable will go into the network port here, and then will be connected into a switch. So the network interface card allows you to connect a device to the network. The network interface card will contain a MAC address, which will be used to identify the computer to the network. So workstations connected to the switch ports, each network card has a unique MAC address, which switches can use to identify a particular workstation. You can also contact wirelessly as well, so it doesn't have to be a physical connection. Right, let's have a look at what a bridge does. So what we may have is you may be building an extension in your office or your school. So a bridge is used to connect two parts of a local area networks together so they can function as a single LAN. The switch or two switches can be connected using a bridge device. So you may have this could be one part of the office connected to a switch, and then you could have another part of the office connected to this switch here. And a bridge device can be used to connect both of these switches together. And it's still going to maintain the local area network. It's not going to be a wide area network. It's just basically bringing two parts of the local area networks together, connecting it. So let's have a look at this exam question now. So network devices are used in computer systems. Complete each sentence by identifying the most appropriate network device. So the network device that connects a local area network to a wide area network is going to be a router. So when you have more than one local area networks to connect it together. So let's say you got two campuses. In each campus, you have a local area network. When you connect them together, you form a wide area network, and you can use a router to do this. A network device that allows data to be directed to a specific computer on a local area network is going to be the switch, because the switch is a smart device. It's going to use a MAC address to send that data to the particular workstation, not a hub, which will basically send the data to all of the computers on the network. Okay, and internal network device that allows the computer to connect to a local area network. You can say network interface card or NIC. I would prefer if you guys write out network interface card. So you can see the interface card will be built into the computer. It could be a separate card or it could be part of the motherboard. Right, guys, let's have a look at the difference between the use of Wi-Fi and the Bluetooth in networks. So Wi-Fi and Bluetooth both use wireless communications, can allow several devices to be connected, and both use security when sending data. However, there's an obvious difference between using Wi-Fi and Bluetooth. Okay, so with Wi-Fi, you have a wider or a broader range in order to connect your devices together, and the Bluetooth devices have to be in a closer proximity in order to be able to connect. When transferring data, data can be transferred much quicker over a Wi-Fi connection compared to a Bluetooth connection. So when I was younger, and you'd be sending a song from one mobile phone to another mobile phone, you'd be using Bluetooth. And it would take a while to transfer that song from one phone to another using a Bluetooth connection. Obviously, with Wi-Fi, you have quicker data transmission rates. Anyway, so let's look at the advantages of using Wi-Fi in your network. So reduce cost of cabling. So we don't need to have every device connected via cable. Safer, you won't have trip hazards. Okay. It's easier to connect additional devices to the network, and then it makes your device portable. Okay, so that's for the Wi-Fi. For the Bluetooth, you can connect wireless devices such as a mouse, a phone, and a headset to your computer, which are in close proximities. That's when we talked about the range. And we can use it to transfer files between devices. So that was the example of the song, MP3. And you can also print wirelessly from a tablet to a mobile phone or laptop using Bluetooth technology as well. Now, the advantage or the disadvantage is if you have a cabled connection to the switch, your connection would be more stable. If you have a Wi-Fi connection, it could be less stable. If you move in from one location to another location, you can lose connectivity compared to a cabled connection. And the strength of the signal could become weaker due to obstacles or your location in a building where maybe you've moved to a different location and the connection is not strong. So, for example, when I go home and if I go to my bedroom, my Wi-Fi connection may drop and it may go to my data instead of being connected to my Wi-Fi. So obviously with Wi-Fi, it could be easier for hackers to hack into and it would be less secure compared to a cabled connection. And also with the Bluetooth, as mentioned, it's a shorter distance of coverage, slower data transfer speeds compared to Wi-Fi, supports a limited number of devices in the network, and there could be security issues when transferring data. So let's have a look at this typical exam question here. So compare the similarities and differences between Bluetooth and Wi-Fi. Bluetooth and Wi-Fi both use wireless communications and allows several devices to be connected. Both use security when sending data. However, Wi-Fi has a faster data transfer rate. Also, Wi-Fi has a greater range of transmissions and can connect more devices than Bluetooth. Bluetooth has a lower frequency than Wi-Fi, so that could be an extra mark if you want to add that. Okay, guys, what I think I'll do is I'll pause at this moment, and the next part of the video, we'll start looking at cloud and how clouds can be used for centralized data storage. Okay, so please drop your comments below. I hope that all makes sense. Please like and share and subscribe to the channel as well. Thank you for your time, and please join me in the next part of this video where we'll look at this section instead. Okay, thank you. Bye-bye.